Dear students, welcome back to Standard 9 Science and Technology Part 1. This is the fifth module of the chapter Laws of Motion. Before beginning, let us recollect our previous module. Newton's first equation of motion is V is equal to U plus AT. That is, it gives a relationship between velocity and time. Newton's second equation of motion, which gives relationship between displacement and time, is S is equal to ut plus half at square. Newton's third equation of motion, which gives relationship between velocity and displacement, is v square is equal to u square plus 2as. In this module, we will be learning about Newton's laws of motion and also about law of conservation of momentum. Children, can you tell what could be the reason for the following incidents? A static object means an object at rest will not move without applying a force. Then, a force which is sufficient to lift a book from a table is not sufficient to lift the table itself, isn't it? Then, fruits on a tree fall down when its branches are shaken. Here, we are not even touching the fruit. You have seen this very often. An electric fan keeps on rotating for some time even after it is switched off. Have you guessed what is the reason behind these incidents? These incidents follow Newton's laws, which we will be learning in the coming slides. Let us begin with Newton's first law of motion by learning an activity. Children, take a glass and fill half of it with sand. This is optional. You can either fill it or leave it empty. Keep a piece of cardboard on it covering the glass and keep a 5 rupee coin on the cardboard. Now strike the cardboard hard using your fingers, like flick it off. Observe what happens. As you can see in the picture, when the cardboard is flicked off, you will see the coin falling straight into the glass. Before judging the reason why this happened, let us learn a concept. One is balanced force. What is it? Balanced forces are the two forces acting in opposite direction on an object and they are equal in size. This you have to keep in mind. They are equal in size. Anytime if there is a balanced force acting on an object, the object either stays still or it continues moving at the same speed in the same direction. This is called as a balanced force. An unbalanced force is when unequal forces are applied to an object on the two sides. An unbalanced force acts on an object, results in imparting movement to that object. If you can see, this is a very familiar incident like a tug of war. Whoever is having high amount of force will be the winner. See the bird moving towards the earth at a great speed. You will see gravity is acting and the friction is acting opposite to the movement of the bird. All these are examples of unbalanced force. In unbalanced force, you will see that one force and the other, they are not equal. Let us come back to our Newton's first law of motion. A stationary object on which no force is acting. Remember our experiment with the coin and glass? The stationary object in that case is the coin. The stationary object on which no force is acting remains stationary. Okay. What happens to an object which is in movement? An object in movement continues to move with the same speed and direction when no force is acting on the object. Children, hope you are now clear for the reason for our experiment. So, an object which is at rest where no outside forces are acting on it will not move. Same way, on a moving object, when no outside forces, the object will not stop. This is Newton's first law of motion. Now children, let us try one more activity. Ask your friend to drop one plastic and one rubber ball from the same height. You catch the balls. Which ball was easier to catch and why? Yes children, the plastic ball was easier to catch because it is lighter and it will be easy. The rubber ball, which is somewhat heavier, falling from a height, may not be easy to catch. Ask your friend to throw a ball towards you at a slow speed. Try to catch it. You know that it is going to be easier. Now ask your friend to throw the ball at high speed. Try to catch it. Which ball could you catch with greater ease? Of course, the ball with a slow speed, it will be easier to catch. With so much speed, it may not be easier to catch the second ball. Children, the effect of one object striking another object depends both on the mass of the striking object as well as its velocity. We can compare the same with the previous activity like catching the ball from a height and catching the ball with a different speed. So this means that the effect of the force depends on property related to what? Both mass and also velocity. Here speed. So the effect of the force depends on mass of an object and speed of the striking object. And this property is called as momentum. I repeat, this property is called as momentum. Children, talking about momentum, momentum has both magnitude as well as direction. So it is a vector quantity. Its direction is same as that of its velocity. The unit of momentum is kilogram meter per second in SI unit and gram centimeter per second in CGS unit. Children, it depends on mass and velocity. Hence, mass, unit of mass is kilogram and unit of velocity, it is meter per second. So, the unit of momentum is kilogram meter per second. It is SI unit and we know CGS unit, the conversion is gram centimeter per second. If an unbalanced force is applied on an object, causes a change in velocity of the object, then it also causes a change in momentum. The force necessary to cause a change in the momentum of an object depends on rate of change of momentum. Momentum is the product of mass and velocity of an object. Momentum is denoted by the letter P, mass as m and velocity as v. So the rate of change of momentum is proportional to the applied force and the change of momentum occurs in the direction of the applied force. Take for example, an object of mass m has an initial velocity u, and when force F is applied in the direction of its velocity for time t, its velocity becomes v. That is, u is initial velocity of the object and v is the final velocity of the object. Therefore, the initial momentum of the object will be mu, that is mass and initial velocity, and after time t it becomes mv, that is mass and final velocity. The rate of change of momentum is the change in momentum in given time, which is mv, that is mass and final velocity minus mass initial velocity in the given time. So we can rearrange a formula in such a way to apply acceleration to it, so that the formula becomes mass into acceleration. So according to Newton's second law of motion, we know that the rate of change of momentum is proportional to the applied force. So therefore, ma, mass into acceleration, is directly proportional to the applied force. So in order to remove that proportionality, we are comparing with the constant. So F is equal to K into ma. Here K is the constant of proportionality and its value is 1. So the equation becomes F is equal to ma. Children, let us consider two objects having different masses which are initially at rest. So the initial momentum will be 0 for both the cases. Take for example, a force F acts for time t on both the objects. The lighter object starts moving faster than the heavier object. We know that very well. We know that the rate of change of momentum, that is F, in both object is same, and the total change in their momentum will also be same, that is F into time t. Thus, if the same force is applied on different object, the change in their momentum will be same. Children, use your brain power. Why is there a thick bed of sand for a high jumper to fall on after his jump? This we have seen in long jumps also. Why is it so? So that the bed will absorb the shock of their falling, isn't it? Let us try this. Take a plastic boat and make a hole under its rear end. Inflate a balloon and fix it on the hole in the boat. Oral children, as given in the picture, you can inflate a balloon and fix it in a place and make a hole in the rear end so that the air will escape in the rear end. You can make it either way. Release the boat in water. What will happen, children? Yes, as the air escapes slowly in the rear end, the boat will move forward, isn't it? In the above activity, the force is applied in one direction and the movement is in opposite direction. Am I right? Newton's third law states the same. It says in nature, force cannot act alone. That means force is a reciprocal action between two objects. That is, forces are always applied in pairs. When one object applies a force on another object, the later object also simultaneously applies a force on the former object. The forces between two objects are always equal and opposite in direction. The force applied by the first object is called the action force, while the force applied by the second object on the first is called as reaction force. So every action force has an equal and opposite reaction force which acts simultaneously. This is more important. The reaction force does not take any time to react. It reacts almost instantly. This is Newton's third law. Children, here are some examples of Newton's third law. See a batsman hitting a ball. The action is in one direction, but the reaction is in opposite direction. You see a cannon firing. So the force on the ball makes the cannon move behind, and propulsion of a rocket. The fuel exerts pressure towards the ground, but the rocket moves above the ground. These are some common examples of Newton's third law. Now children, let us discuss about law of conservation of momentum. What is this? Take an object A which is having a mass m1 and its velocity is u1, which is initial velocity. Take another object B which has mass m2 and initial velocity u2. So according to the formula for momentum, the initial momentum of A will be m1 u1 and B will be m2 u2. This we know. Suppose these two objects collide. What will happen? Let us consider the object B strikes the object A. So the force on A due to the striking of B will be F1. So this force, what will happen? It will cause acceleration, that is movement of the object A, and its velocity becomes V1. So because it is attaining final velocity V1. So momentum of the object A after collision by the object B will be equal to m1 v1. According to Newton's third law, we know that A also exerts an equal force on B, but in the opposite direction. So this will cause change in momentum in B also, isn't it? So if its velocity after collision is v2, the momentum of B after collision will be m2 v2. So after collision of two objects, an object A after collision becomes m1 v1. The final velocity after collision of object B is V2. So the momentum becomes M2 V2. So if F2 is the force that acts on object B, F2 will be equal to minus F1 because the force is opposite in direction. So we already know that force F is equal to mass into acceleration. Let us apply this here. Therefore, M2A2 will be equal to minus M1A1. This is what happens when two objects collide. When we solve this further, that is M2A2 is equal to minus M1A1, we know A acceleration is equal to V minus U upon T. So substituting according to those two objects, so M2 is V2 minus U2 upon T. The time is going to be same for both, that we know very well, and minus M1 and V1 minus U1. When we cancel out T on both sides, so the equation changes. When you cross multiply within the bracket, you get this step M2 V2 minus M2 U2 will be equal to minus M1 V1. This minus into minus become plus, so the equation becomes M1 plus M1 U1. So let us take the V on one side and U on other side. We are rearranging the equation. We will get the magnitude of total final momentum. So this is the magnitude of total final momentum is equal to the magnitude of total initial momentum of both the object. Is it clear, children? Thus, if no external force is acting on two objects, then their total initial momentum is equal to their total final momentum. This is true for any number of objects. So, we have learnt that when no external force acts on two interacting objects, their total momentum remains constant. It does not change. This is called law of conservation of momentum. Children, this law is a corollary, that is follow-up of Newton's third law of motion. The momentum is unchanged after the collision. The momentum gets redistributed between the colliding objects. So the momentum of one of the object decreases while that of the other increases. Hence they become equal. When two objects collide, the total momentum before collision is equal to the total momentum after collision. Children, let us consider a bullet being fired from a gun. When a bullet of mass m1 is fired from a gun of mass m2, its velocity becomes v1 and momentum becomes m1 v1. Here two objects are bullet and gun. Before firing, both the bullet and the gun are at rest. So what happens? Initial momentum is 0. So according to a law of conservation of momentum, the total final momentum should also be 0, isn't it? The forward moving bullet causes the gun to move backward after firing. You can witness it very well in the picture given. This backward motion of the gun is called recoiling. So the velocity of recoil, let us take it as v2. So according to law of conservation of momentum, m1 v1 plus m2 v2 should be equal to 0, or v2 can be calculated as m1 upon m2 into v1. Hope you have learned so much in this module, children. Shall we summarize the points? A stationary object on which no force is acting remains stationary. An object in motion continues to move with the same speed and direction when no force is acting on it. This is Newton's first law of motion. The rate of change of momentum of a body over time is directly proportional to the force applied and occurs in the same direction as the applied force. That is, force F is equal to ma. This is Newton's second law. So every action force has an equal and opposite reaction force which acts simultaneously. This is Newton's third law of motion. So when no external force acts on two interacting objects, their total momentum remains constant. It does not change. This is law of conservation of momentum. And also we have learned when two objects collide, the total momentum before collision is equal to the total momentum after collision. Thank you so much for listening to this chapter, children. Have a great day.